Hello and welcome back to Business Analytics. This is Hari Rajagopalan and I will be continuing this lecture on time series forecasting for you all. So we finished descriptive analytics, we are in predictive analytics, and we are focusing on time series forecasting right now. So in this lecture, we're going to look at very simple forecasting models. They're suitable when no trend or seasonality is available, or you can try and the basics is that we're going to try and reduce and flatten the errors and try and display patterns. Sometimes it is useful when there is a trend because you can kind of flatten the up and down fluctuations and tease out the actual trend. And so the forecasting methods we're going to discuss are simple moving average, weighted moving average, and then moving average smoothing. So let's talk about simple moving average. This basically allows you to smooth time series data and reveal underlying trends. And the smoothing aspect is the process of removing random variations. It reduces noise and emphasizes the signal. We can also call it filtering data. The basic assumption here is that observations closer in time are likely to have similar values, and averaging removes random variation. So simple moving averages are calculated using sequential segments of data points. They have a length, which is the number of data points to include. And let's take an example. We have electricity, which is a retail store which sells audio and video equipment. And each month, the manager of the store must order merchandise from a distant warehouse. Now, currently, the manager is trying to estimate how many DVRs the store is likely to sell next month. And he's collected data from the previous 24 months. Now, he wants to use these data to make predictions. And here's the data set. So he's got 2 years of data, and here's the number of DVRs sold per month. And always as we look at it, and we'll go through Excel, we'll first plot the data. Then we are going to create a simple moving average for 2-period, 4-period, and 6-period moving average. And we're going to calculate the root mean squared error, MAD and MAPE. So here's the data. Let's move to Excel, and we will plot the data just to get this structure. And then we'll also look at a different plot to see whether we can tease out some of the trends or seasonality. So let's do that. Let's move on to Excel, and I'm going to stop right here. Okay, so before we get into the how to get this final result here, let's kind of just copy the data. So the data set which you have, this is the data set, and I'm going to just copy it and paste it here. So this is all you normally see. You see 2 years of data, right? Time period and DVR sold. You can go to insert, you can go to graph, and I always use this scatter with straight line and markers. Okay, so you can see this kind of going up and down. Sometimes, just to accentuate the difference, people do use this to kind of change the minimum. But if you do this, you need to tell your audience that you have actually changed your axis intercept from 0 to 25 to essentially enlarge the difference. Otherwise, it can be misleading. Okay? So if we are looking at, and this is essentially the entire data set, but if we want to look at yearly, so let me go here, and I'm going to look at the yearly data set. This is for an entire year. And we're going to edit this axis 1 to 12. And then we can add the next year right here. Oops. Year 2. And Y values, this is for year 2. So if I wanted to year 1, So if I wanted to take a look at this, and this would give me an idea of if there is a trend. So it's slightly above, but then it goes lower here. So there is really no trend from year one to year two. And when we look at trend and seasonality, this kind of graphing actually makes a big difference. So now let's look at the moving average, simple moving average, and let's look at 2-period simple moving average. So we skip the first 2 periods and go to the 3rd period and take the average of the previous 2 periods. This is your simple moving average. Okay, and you can go right up to this point. All right, so here we go. This is your 2-period moving average. You can also get 4-period moving average. What do? You skip 1, 2, 3, 4, go to the 5th period and find the average. Now remember, the forecast is always does not take the values of its time period. The forecast always uses previous time period. So you've got to use previous 4 time periods. All right. And then 6-period moving average. You go to time period 7. Make sure you pick the right time period and find the average of these 6 here. All right, and that will give you a 6-period moving average. How do you know how good they are? You can calculate your root mean squared error, your MAD, MAPE. Remember, your root mean squared error requires your mean squared error, so you can do MSE, and here it's sum x my2. Remember to make sure sum x my2 is selected. Array 1 is this, array 2 is this, and then you're going to count your data set. I normally try and use the actual data here, so this gives you your mean squared error. Now I would go ahead and fix B5 to B26 because that's not going to change. However, C5 to C26 might change depending upon what we are using. So this is your mean squared error. Root mean squared error is given. Go ahead and set the number here. Your MAD would be, and if we remember the formulas, this would be the average of the absolute difference. Again, here this would be an F4 value with both dollars everywhere, minus this. This is your, and then you close the second bracket. This is your MAD. MAPE would be average absolute F4 minus this. This is divided by, again, this here, these values, and that should be it. All right. Now, you can copy these across, but you've got to make some edits. So let's look at the edits. So first one here, this, you got to reduce these to where the data is. And this one would go all the way down. So if you're going to use the copy function, make sure you check and make sure you do the edits. These don't change. These are fine. These need to be edited. Again, and this one too. And Same here. Right, so make sure you check, because it's very easy to forget and miss out something when you copy and paste stuff. So make sure that these are all done correctly. So here you go, and now we can actually do a thing for, here is your here's the graph, right? Here's the graph, format axis. We can kind of expand it so we can see it a lot more clearer. And you can see 2 period versus 4 period versus 6 period. 6 period is a lot more smoother from it. So here we have the 2 period, 4 period, and 6 period moving average, and the mean squared error, and the MAD and MAPE. Notice the difference between 2 period and 4 period when it comes to MSC and MAD. MAD, as the number of time periods increase, their error reduces. So does MAPE. Why? Because MAPE is pretty much uses absolute error, right? But look at MSC. MSC increases then decreases. So if you look at the 2 period moving average is the lowest, whereas these two are higher. Well, what's happening? Let's take an example like number 15. This is 32, this is 38.5, and this is 38.17. So what happens is a difference of 6.5 in absolute value does not affect MAD and MAP as much as when you, this negative 6.5, and you square it, comes to almost 40. So that these big variations affect MSC and RMSC a lot more. So if you were choosing MSC, you might think that a 2 period moving average is better, has lower error than 4 and 6. However, when you do MAD, when you look at the absolute values, you can see that there is a difference there. Okay. All right, so let's move on. So here are the formulas which we talked about, MSC. Don't forget to put a $sign in B5, C26. Same thing here. You can see that there's the $sign. And here are the formulas to calculate these values. So we've already gone through Excel and worked it out. This is just a summary of what we did. So here is our graph. That is the 2 period moving average. That is the 4 period moving average, and that's the 6 period moving average. Now we're going to discuss a second kind of method, we call it weighted moving average. The difference between simple moving average and weighted moving average is that in simple moving average, each data point, whether it's 2 periods or 4 periods or 6 periods, they're treated equally, they're weighted equally. In 2 period moving average, each data point is given 50% weight. In a 4 period moving average, it's 25%. But in weighted moving average, you are actually looking at a way to reduce your error and therefore weighting the data points differently. So let's look at doing WMA for 2 period, 4 period, 6 periods and calculate the errors. Okay, so same data set, and we're going to do 2 period, 4 period, and 6 period here. Here are the weights we're going to use, and we're going to go through this in Excel and talk about it. All right. So we'll start with equal weights. For 2 periods, these two will be 50%. For 4 periods, they'll all be 25%. For 6 periods, it'll be 16.67%. And then we will actually use something called an optimizer, which all of you have installed, the solver, and we will walk through this whole process in Excel. All right, so let's focus on weighted moving average. And again, I'm going to start with just copying these and do one weighted. Let's do 2 period weighted moving average first. Okay, so let's copy this. We're going to do a 2 period weighted moving average, which means we go to the 3rd period, right? And let's assume this is weight 1 and weight 2, right? So let's assume we give it 50% each here. Let's go ahead and format it. So here is 50%. So this is something I want all of you to remember, is that the first weight is linked to the time period immediately before the forecasts, okay? And the second weight is then further beyond. Now this is something a lot of you make mistakes in, because you start with W1 going for time period 1. That's not right. W1 is the time period immediately before the forecast. So don't forget that. That definitely will cause problems for a lot of you. So make sure you get that right. Don't forget to put the $sign. And once you do that, you can copy this all the way down up to this point. Okay. And then you can calculate your, I'm just going to go ahead and you can calculate your mean squared error, your root mean squared error, your MAD, and MAPE. Okay, so your mean squared error is going to be sum xmy2. We get array 1, comma array 2 divided by either you're going to count the count of C5 to C26, or you can do B5 to B26. Either one will do. So this is your mean squared error. Okay, so this gives you a 2 period moving average. I'm just going to move this right here. You can get the root mean squared error. And I am not going to do the rest, because I think all of you should know by now how to calculate the other the data which is given to all of you. Okay, so we can do MAD and MAPE also. Now, but this doesn't stop right here. So now all of you should have installed Analytics Solver. If you haven't installed Analytics Solver on your Excel, make sure you do. Make sure it's not the web version. Make sure you have the desktop version. And go to optimizations. And the objective here, you're going to minimize the MSCE. You can minimize MADE also, but MSCE works better with these optimizers. And that's why, while MADE is more accurate, it's more difficult to do stuff with. So we normally use MSC to do the optimization. So here, these are the variables, and the constraints are, these variables are greater than or equal to 0, right? And you can either put these variables are less than or equal to 1. You can do that, or you can delete that and you go to engine and you can say assume non-negative is true. If you have assume non-negative is true, then you don't need this constraint. Okay, and then when you run it, you get the information which minimizes, let me just move this here. So 29% of the previous time period and 70% of the 2 time periods ago of that data is included, and that minimizes your error. Okay, so let's go back here, and you can see we have actually done that here, and here's the MAD and MAPE and so on, right? And you can do the same thing. You can copy and paste this, right? And you basically create a new sheet here, and then you do 4 period WMA, right? So you basically move 1, 2, 3, 4. Now you have W1, W2, W3, and W4. So you use 25%, or you can do equal to 1 by 4 and copy 1, 2, 3, 4, right? And do it. The thing is that you have to show, you have to do separate sheets for 2, 4, and 6, because the solver here can only show for one worksheet. So you can't have multiple worksheets, kind of doing that. So my suggestion is to do a separate one for each worksheet. I think by now all of you are comfortable. What I've done is I kept a standard. I created all 3 here with these standard, right? 25%, and then here this will be 1 by 6 here. All of them will be equal to 1. Some of these should be equal to 1, right? And then I optimized for 2, then I copied it, then I optimized for 4, copied it, and then I optimized for 6. I'm not going to do each one. I think all of you can practice and work through that. So this finishes our weighted moving average function. So back to PowerPoint. So we finished weighted moving average, right? And we can we worked through the Excel. We made sure the weights. So here we minimized mean squared error, right? You can minimize MAD also, but mean squared error is better. We looked at the weights here, depending on which period. Some of the weights are equal to 1, and we basically weight should be between 0 and 1, and we ran that through Excel. So here are the graphs for the different moving averages. And now we're going to come to the last simple, the level-based forecasting methods. We're going to use exponential smoothing. So exponential smoothing uses something called a smoothing parameter. It's called alpha. Alpha is a value between 0 and 1, so it's a percentage. And essentially what alpha is it gives us the percentage of new data to use to update your existing forecast, which is your level, because we are assuming only level. So our prediction is previous time period, right? Previous time period's forecast, whatever our forecast is, plus alpha multiplied by the previous time period's error. So we're taking whatever the error is, and we're taking a certain percentage of the error, right? We're using alpha, and we're adjusting our previous forecast. So if you say alpha is 10%, we're taking 10% of the error. If it's positive or negative, we're taking 10% of the value and adjusting the forecast. If it's negative, it'll reduce the from the previous forecast. If it's positive, it'll add to the previous forecast. So let's take an example. Same example. We start with alpha of 10%, and then we try to find the best alpha by minimizing our error. So same example, here's the data, and we'll start with 10% and then optimize. Again, we are going to use the solver, and you can see we minimize MSE or MAD. I would suggest we stick to MSE. Alpha is your changing cell, and we are going to say alpha is between 0 and 1. So let's go to Excel, and this is the last for level, the forecasts which do not look at trend and seasonality. Okay, so walking through exponential smoothing, I want you to understand how this is done. So I'm not going to go over MSE or MAD or RMSE here. We will start with, let's go ahead and start. I'm just going to go ahead and copy this. I'm going to paste it here. I'm going to delete all these values, including this. we'll start alpha of 10%. Okay, so it's customary to kind of say the first it's called initialization. So we're going to initialize it the first time period with the first value. And now we're going to say your prediction, right? Your forecast is your previous time period's forecast plus alpha. Make sure your alpha is F4 multiplied by the difference between your actual and your previous forecast, right? Remember, it's the previous time periods. So you're looking to see if there's any error in the previous time period. If there is, then you take 10% in this particular case. You take 10% of that error and adjust your forecast, right? So if this was, right now this is 0, so you don't really have to adjust your forecast. But now if we come to the next part, remember, this is 38 and this is 33, so there's an error of 5. It's positive 5. And so now we are taking 10% and we are adjusting our forecast to 33.5. But now we have over forecasted and the difference is about negative 2.5. So now 10% of that, and we reduce the forecast. Again, here now this is more, about 4.75 more. And so now again, you can go ahead and that would give you the answer. Anything beyond this point, it will be the same value. So you will just kind of go, it's basically the same forecast. Forecast cannot change beyond this spot, okay, because you don't have data. And this is the final forecast, 35.94. And so again, the optimization is we are trying to minimize your mean squared error. So you go double click here, click on MSC. Your only variable here is alpha, which you need to optimize, and your alpha is less than 1, right? And you can go to engine here, say assume non-negative is true, which means you don't have to say it's greater than 0, and you can run it to give you, it will take 26.79%, and it will give you a mean squared error of 7.82 and an MAP of 2.1. Okay, so let's move to the end. This is, of course, our actual, and this is the prediction. You'll notice that exponential smoothing tends to smooth the up and down fluctuations. And for the next lecture, we'll start looking at seasonality, how we're going to incorporate forecasting with seasonality, what are the different kinds of seasonality. We'll particularly be focusing on additive or multiplicative. And for you to have an example, here's an example of seasonality. You can see up and down, International Visitors Night in Australia, and the difference between additive and multiplicative forecasts. We'll talk about that in our next lecture.